Okay, here we go. Here are the three problems you requested. First up, we have from your Unit 1, Unit 2 review number 11, which read the slope of the tangent line to the curve, y cubed x plus y squared x squared equals 6 at 2, 1 is. Okay, slope of the tangent line, we should know our calculus term for that. When you see slope of the tangent line, okay, that means derivative. And so they're asking us, what's the derivative at this point? And so after we take our derivative, we're going to be plugging in 2, 1. Right? Okay, so taking the derivative of y cubed x plus y squared x squared equals 6, with this y cubed x term, I notice I have two things being multiplied together. So this is product rule. Right? So we have our 1 and our 2. So 1, which is my y cubed, d2, derivative of x is 1, plus my 2, which is my x here, d1, derivative of y cubed, is 3y squared. And then because we're taking the derivative of a y right here with my d1, right, derivative of y cubed is 3y squared, I need to tack on a dy dx at the back, acknowledging the fact that I'm working with a y instead of the x that I wish I was working with. Right? So again, this product rule, 1 d2 plus 2 d1, don't forget the dy dx. Okay? Plus, we have our second term also has a product rule component, right? Y squared and x squared are being multiplied together. So we're going to do the same thing. We have 1, which is my y squared. d2, derivative of x squared, is 2x. Okay? Plus my 2, which is the x squared. d1, the derivative of y squared, is 2y. And then again, we took the derivative of y, so this is dy dx. Acknowledging that we're working with the wrong variable, right? Or the dependent variable, I should say. Okay. So this is the first two terms, and then we have equals, the derivative of 6 is 0. Okay, so if you look in your 2.5 notes, which is where this is from, this is implicit differentiation, right? This is our first step, is to take the derivative using whatever rules you need to use, right? Product rule, quotient rule. Anytime you take the derivative of a y, make sure to tack on a dy dx, right? That's that first step. Okay, second step is we need to separate the terms that have a dy dx, these two, from the two terms, or however many there are, that don't have a dy dx. And so this y cubed and this 2xy squared, I'm going to subtract over to the other side, separating them from my dy dx terms. So I'm going to subtract this y cubed over and subtract this 2xy squared over. Okay, and so we're left with, on this side, 3xy squared dy dx plus 2x squared y dy dx. Okay. These two terms that have the dy dx's. And then that equals my negative y cubed minus 2xy squared. Okay, so that's the second step. Third step, we need, now that we have them separated, the dy dx terms away from the non-dy dx terms, I need to factor out this dy dx piece so that I can divide the remaining. Right, so I'm going to factor out dy dx. And so I'll be left with 3xy squared plus 2x squared y. 3xy squared plus 2x squared y. And at that point, I can divide this term. And that'll get my dy dx completely by itself. Okay. So we've got this term over here divided by this term. Okay. Okay, and so since they asked us to find the dy dx at this point, I'm going to go ahead and now plug in 2 into my x, 1 into my y. Okay. So y cubed, or 1 cubed, is 1, minus 2 times my x, which is 2, and y squared, 1 squared, which is 1, all divided by 3 times my x, which again is 2, y squared, 1 squared, which is 1, plus 2, x squared, so 2 squared is 4, and my y, which is 1. And so I just plugged everything in. And then you just simplify it from there. Okay, so we have -1 minus 2 times 2 times 1, which is 4. 3 times 2 times 1 is 6, plus 2 times 4 times 1, which is 8. And -1 minus 4 is -5, over 6 plus 8, which is 14. Okay. For the record, if you girls would like to, you could potentially plug in your x's and y's up here. If you prefer manipulating numbers instead of variables, like I manipulated my variables all the way down. If you wanted to, you could plug in, 1 cubed here, and your 2 here with the 1 squared, etc., etc. You just would want to make sure you didn't plug into dy dx. They didn't give me dy dx. They asked me to find dy dx. They only gave me x and y. And so you could plug the x and y in, and then you would have whole numbers. You'd still generate -5 over 14 if you wanted to do it that way. Okay. Next up, we had from your Unit 3 worksheet, number 8, which says, at which of the 5 points on the graph of y in the figure are dy dx and d squared y over dx squared, or in other words, at which of the 5 points on the graph of y in the figure are the first derivative and second derivative both negative? Okay, so I have my graph of y here, 5 points. I need to first figure out what does it mean for a first derivative to be negative, as in what does that look like on a graph, and then the second derivative to be negative. Okay, so first derivative, we just kind of touched on that in the prior problem too. Remember, a derivative means slope, right? That's kind of our synonym. And so for my slope, my derivative, to be negative means my graph has to be going down, right? Like this pen has a negative slope because it's going down, right? And so that's the first thing I'm going to be looking for, is any point that isn't on a downwards slope can't be my answer, right? Both my first derivative and my second derivative have to be negative. And so if my point's on an upwards slope, there's an issue, right? So first derivative negative means the slope has to be negative. And so A here is on an increasing part of the graph, right? The slope is positive, and so it can't be A. Same with E here. E's on an upwards part as well. B and C are both on a downwards part, so they could potentially be the answer. D looks like it's probably a 0, right? If I drew in my tangent line here, it looks like it's probably horizontal. But I would encourage waiting to cross off D just to make sure it's not like slightly negative, right? So I would kind of maybe question that one, but maybe don't nix it yet, right? And so then we're going to look at this piece of our requirements, the second derivative, the concavity, right? This has to be negative as well. Okay, so second derivative, again, deals with concavity. If my second derivative is negative, that means my concavity has to be concave down, right? Down like a frown. And so that's going to be the next criteria I'm going to be evaluating my remaining points against. Are any of these points not concave down? Second derivative, not negative. Okay? Well, here's my concave down piece, and somewhere in this range, I switched from being concave down to concave up. Remember back in that unit we talked about the fact that it's about halfway, right? It's an ish, but it's about halfway is our point of inflection when we change concavity, right? And so right around here, we change from being concave down to concave up, which means C and D are both on the concave up piece, right? My concavity here is positive because it's concave up, and so they couldn't be the answer because my concavity wouldn't be negative there. And so my answer has to be B, because on B, my derivative is negative, negative slope, and my concavity is negative, concave down. Okay, last one that you requested here, which was number 15 on your unit 4. We were asked to take the antiderivative of the quantity of x minus 1 root x dx. Okay, so this is where you need to see, can I turn it into power rule, or is it a u du? Okay, and in this case, there's no exponent on this quantity, so I can distribute this x to the 1/2 into my parentheses. right? And that'll turn it into power rule. It'll be in the form x to an exponent. Right? So when I do that, I have x times x to the 1/2, which is x to the 3/2. Because remember, when you multiply like bases, you add their exponents. 1 plus 1/2 is 3/2. Minus 1 times x to the 1/2 is x to the 1/2. And so now we're in the form x to an exponent, right? Which means now I can add 1 to the exponent and divide by the new exponent. So 3/2 plus 1 is 5/2. Divide by the new exponent. Right? And then x to the 1/2, add 1 to the exponent, is 3/2. Divide by that new exponent. And then don't forget the plus c. Okay, and the last step here, dividing by a fraction is the same thing as multiplying by its reciprocal. So dividing by 5/2 is the same thing as timesing by 2/5. Same with over here, dividing by 3/2 is the same thing as timesing by 2/3. And there you go. Good luck studying. I'll see you tomorrow.